Okay, in this video we're going to be talking about piecewise functions. Okay, so remember, if you want to rewrite this, f of x also means the same thing as y, so this one here is y equals x squared, this is y equals 6, and this is y equals 10 minus x. Okay, so we know what an x squared graph looks like, so what I like to do is use pencil. X squared graph starts at 0, 0, goes right one up 1, right one up 1, 2, 3, right one up 1, 2, 3, 4, 5, left one up 1, left one up 1, 2, 3, left one up 5. I like to draw it in and then look at my restraint. So my restraint, x is less than 2. So I want all of the graph that is less than 2. So I'm going to go to 2, which is right here, and I want to erase everything on the right of it. Okay, here's how I double check. If I plug in 1, 1 is less than 2, which is true. So I want all of those points that would make that true when I plugged it in. Okay, so now my next one, we got y equals 6 at x equals 2. Okay, so that's a point. It is 2, 6. Okay, so equals means it's at that spot. Y equals 6 is generally a line that goes this way, but because it only equals 2, it's actually going to be a point at 2, 6. So right 2 up, 1, 2, 3, 4, 5, 6. My next one is a line. So it starts at positive 10, it goes down 1, right 1, down 1, right 1, down 1, right 1, down 1, right 1, and keeps going. Has arrows on it because it's a line. Okay, and then I'm looking at my restraint. X is greater than 2, so I'm going to erase everything that's less than 2, but it is less than 6. So it basically sits in between 2 and 6. Okay, so I'm going to erase everything that's past 6. 1, 2, 3, 4, 5, 6. But then also less than 2, which is going to be up in there. And there is my piecewise function. So when I do my domain, because it's got the arrow on the left, it goes from negative infinity, and because it stops at 6 over here, and it's a closed dot, we're going to end it like this. The lowest it's going is my parabola down here, which is 0. And then because this arrow keeps going up, it's going to go from 0 to infinity. Okay, my next one here, we got y equals 2 and y equals the absolute value of x. So y equals 2 is a horizontal line, and I want everything less than 1. So like I want everything to the left of 1. So I go to 1 on my x here, and I erase everything to the right of it. Okay, my absolute value graph then is the V shape. So it starts at 0, 0, goes up 1, over 1, up 1, over 1, up 1, over 1, up 1, over 1, up 1, over 1. And it's going to mirror off the left side here. But if I look at this restraint, I want everything, I'm eating the x. So I want everything that is bigger than 1 this time. Okay, because if I plug, let's say I plug 2 in here. I'm eating the bigger number, so I want to include that 2. So this time I want to make sure I don't have anything to the left of 1. Okay, and because, oops, there's no line underneath, it's going to be an open dot at 1 because it's not including that 1. Okay, and then it's going to keep going forever and ever to the right. So my domain, because the arrows keep going left to right, it's going to be negative infinity to positive infinity. Ooh, so all real numbers. The furthest down it goes is 1, but it's an open dot, and it keeps going up forever and ever, so it's going to go to infinity. Okay, my next one here, we got a line, so it starts at negative 2, goes up 1 to the right 3, 1, 2, 3, up 1 to the right, 1, 2, 3, or down 1 to the left, 1, 2, 3, 1, 2, 3, 1, 2, 3. So that's what I have right now. My restriction, I want everything less than 0. So like -1 would be true, -2 would be true. So those are the ones I do want. So everything that is greater than 0 on my x-axis, I erase. I check to see if it's an open dot or closed dot. It is a closed dot because it's got the little line underneath. Okay, my next one, we start at +3. Go up 1, right 1, up 1, right 1, up 1, right 1. And this time I want everything bigger than 0. So examples, if I put 1 in there, 1 is bigger than 0. I'm eating the bigger number. So I want everything bigger than 0. And this actually has to be an open dot because there's not a little line underneath it. So I'm going to go back. I'm going to erase that, do an open dot, and then do my up 1/1. So it's going to shoot off like this. Okay, left to right, we're all good. It goes from my arrow this way to my arrow this way, so all real numbers. The range is tricky. So we have this down arrow, -infinity, but coming up, it actually stops at -2 and then starts back up at +3 with an open dot, and then my arrow continues forever and ever. All right, my next one here, we got a line, so it starts at 2, goes up 1/1, up 1/1, up 1/1, or down 1, left 1, down 1, left 1. Okay, I want everything that is less than -1. So I'm going to keep this going. And then at -1 on my x, I erase everything to the right of it. Check to see if it's an open or closed dot. It is an open dot, so I'm going to go back and erase that. Put an open dot there. Go to my next one here. X squared graph, so it's going to be a U. So right 1 up 1, right 1 up 1, 2, 3, left 1 up 1, left 1 up 1, 2, 3, 1, 2, 3, 4, 5. So right now we have this. I want it to sit between -1 and 2. So I want to erase everything that's past 2 and past -1. Okay, and then check to see if they are both closed dots, which they are. My next one is a y = 3 line. So if I go up 1, 2, 3 on my y-axis, it would be going like this. But I want everything that when I plug it in there, it's true. So if I plug 3 in here, I'll be eating the bigger number, so I want everything bigger than 2. So I'm going to erase everything to the left, if I can. Okay, and then it is an open dot. So I'm going to put an open dot right there. Okay, domain. From left to right, we're good for all real numbers. There's no jumping that happens. Okay, my range here, it's got the arrow going down, so I got -infinity, but the highest it hits at is y = 4. And because there are closed dots there, we're going to make it a bracket. Even though there is one open dot, there's a lot of closed dots, so that overrules that open one. Okay, my next one here, got my parabola. Okay, and I want everything less than 2. So 1, 2, 3, 4, 5. So I want that whole U that's left of 2. So if you want to double check, if you put a -1, I want the left side of that 2. And I needed an open dot at 2. So I'm going to erase that, put an open dot. Okay, my next one, it's y = -1. Oops, -1. So I go down 1. It's going to be here, but I want everything greater than 2. So if I plug in 3 there, I'm eating the bigger number. So I want everything to the right of that 2. And it is a closed dot. Okay, so I got arrows going left and right. So my -infinity to +infinity is good. The lowest he goes is -1. This one's weird because there's not an actual line there. It doesn't move up and down. So we're going to say -1, and then we're going to start back up at that U. So that U is 0 to +infinity then. Okay, my next one here, we got our first line. So up 2, go up 2 over 1, up 2 over 1, up 2 over 1, or down 2 left 1, down 2 left 1, down 2 left 1. I'm going to keep it going here. Okay, and then I want everything less than -2, so I'm going to erase everything to the right of -2. And then check to see if it's an open dot, which it is. So I'm going to make that little guy an open dot. Okay, this is y equals 3, and I sit between -2 and 3. So I go y equals 3, and I have to have it sit between -2 and 3. -2 is a closed dot, 3 is an open dot. And then I got y equals -x, so plus 0, it's going to start at 0, 0, and it's going to just go down 1 and over. And I have to have everything bigger than 3 this time. So I want to erase everything to the left of 3. One, two, three. And that's a closed dot, so that should be good here. Okay, so my left to right, we got arrows going, so all real numbers. The lowest he goes, because we have that arrow, is -infinity. It stops at -2, and it's an open dot, and then it continues back up at that 3. So we're just going to say 3 because it's not a line that continues left or up and down. It's just a straight across. So we're just going to say 3. Okay, my next one, x squared minus 3. So my u is going to start at 0, -3. Right one up 1, right one up 1, 2, 3. Right one up 1, 2, 3, 4, 5. Left one up 1, left one up 1, 2, 3. Left one up 1, 2, 3, 4, 5. Okay, and then I want everything less than -1. So erase everything to the right of -1. And it's a closed dot, so that one's good. And it continues forever to the left. Okay, my next one is a line, so it starts at 1. It goes down 2 to the right 1. And we're going to want everything bigger than 2. So I'm going to continue it past that 2. Erase everything to the left of 2. It is a closed dot, so that's good. And it continues forever this way. And then we got my cubic. So it's the skinny s in the center. It's 1, 7, 19 up. So I start at 0, 0, right one up 1, right one up, or right one up 1, 2, 3, 4, 5, 6, 7. Left one down 1, left one down 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. And I want it between -1, which is right there, and 2. So I need to stop it right out here, and 2 needs to be an open dot. I need to erase that dot down there. Okay, so my domain, it continues farthest to left, farthest to right, so we got all real numbers here. Okay, it looks like there's a break, so it's going from -infinity. It stops at 3. It's a closed dot, so I can do a bracket. And then it starts back up at -2. Oh, that was a -x cubed, so it should have been flipped. Hold on. -x cubed, so we're actually going to flip it here. So I start at 0, 0, left one up 1, left one up 1, 2, 3, 4, 5, 6, 7, right one down 1, right one down 1, 2, 3, 4, 5, 6, 7, and it sits between -1, so I can erase this dot out here, and 2, and it's a open dot at 2. So it looks like this. All right, so all real numbers is good. Let's fix this then. So we got our arrow going down, so -infinity. It all connects. There's no breaks happening from bottom to top, so it's going to go to +infinity. Okay, and then let's go ahead and do this one because we haven't done one like this. So it's a skinny S at 0, 0. Right one up 1, right one up 1, 2, 3, 4, 5, 6, 7. Left one down 1, left one down 1, 2, 3, 4, 5, 6, 7. Okay, and I want everything less than 1, so I want all of this. And it's a closed dot. I'm going to erase that other dot. My next one's the shooting star, so 0, 0. It's the opposite of my parabola, so it's going to be 1, 3, 5 to the right. So it starts at 0, 0. I'm going to want everything bigger than 1, so basically everything to the right of 1. So that 0, 0 I'm not going to want, but it would go right 1, up 1, or up 1, right 1, and then it would go up 1, right 3. 1, 2, 3. So it'd start at 0, 0, up 1, right 1, up 1, right 3, up 1, right 5. 1, 2, 3, 4, 5. And I want to have everything bigger than 1. So pretend that little origin dot's not there. I can't erase him very well. Okay, and then it was an open dot at 1, shooting off. Okay, so I've got my all real numbers because my arrow going down and my arrow going up, and then there are no breaks from, or there are no breaks from left to right, and there are no breaks from bottom to top, so it's going to be both all real numbers. Okay, labor cost at the fix-up auto repair shop is $60 per hour or any fraction thereof. Draw a graph that represents this situation. So this is actually going to be a jump. So we start at 0 hours, $0. We get 1 hour, we have $60. 2 hours, we have 120. 3 hours, we have 180. And then 4 hours, we have 240. So this is going to be my hours. And then my left side here is money. So I start at 0, 0. Okay, and then my next one, let's move all of this down. Hours. 1, 2, 3, 4, 5, 6. Okay, so my 1 hour, we are gaining that 1. This is going to be my 60. And then let's have, what am I going to go up by? 120, 180, 240. Okay, so then my next one here, I would start at 120, be going to my next set. So it's kind of like this weird little jumping graph where you're making money across that hour, but since it's a consistent $60, it's $60 for every set hour. It's not increasing by minute. So it's going to keep jumping like this. It's going to be a little stair step. Okay, so this one, a downtown parking lot charges $2 for the first hour and $1 each for every other hour. Okay, so again, these are all just going to be stair-stepping jump ones.